So welcome to my tech talk on retrievals from StrongLink, new workflow, and Outlook. Um, yeah, so I had a similar tech talk already 2 years ago, where we presented already new tools and we improved them now based on our experience or based on bad and good experience. So the here's again, if you don't, but the link is now in the chat already. We can skip this slide. If you have any questions anytime, just contact us via support@dkz.de. And so in the beginning, I will briefly talk about our tail archive and problems with the existing tools. So those of you who know them already quite well and only see the new tools and no, let's say, way towards these tools, this first part will take 10 to 15 minutes. So if you want to do something else, you can do so. Come back in 10 to 15 minutes. But I think it might be reasonable for everyone to listen to this. Another point might be a bit off topic, but since we are sitting all the day at the desk and don't move much, at least I for myself can say it. Therefore, I started to add a few short breaks in my tech talks where I do a short relaxing shoulders. And this time I will also stop talking in these breaks because I read that when we have meetings, it could be a good idea to have really a break, 1 or 2 minutes where nobody is talking, just that we can clear our mind a bit. And therefore I would this time just do a short relaxing session and down talk in this time. So maybe you can collect questions in this time. I hope you're okay with this. So let's start with the tape archive. So most of you probably remember these music tapes from the past. And so they are quite robust, they are long lasting, and the same applies to the tapes we use to store data. They're relatively cheap compared to other storage technologies, and and we have many decades of experience with this technology, which is quite a good thing when we want to archive data for long term. It's good not to use really the newest technology, which might have some issues or might have issues in 5 years. And what's quite nice with music tapes, and I thought actually originally it would be the same with our tapes, is when I am listening to music on a music tape, and there's quite a good song. Then I can stop the tape, take it out, go to a friend, insert the tape there, and then just continue playing the song. And this possibly because we have two wheels there. Actually, when we have our data tape at DKRZ or in any other tape library, there's only one wheel on which the magnetic band is on, which means if we have retrieved a file from a tape in the middle, then we have to rewind the whole tape before we can take it out. So we cannot just take it out the tape in the middle as we know from music cassettes. And this is quite important to remember because it slows down certain processes. And what is also quite important to remember, if we, for example, have a music tape and want to play 3 songs from this tape, and maybe they are at different locations of the tapes, then we have to spool quite long. And if the songs are only short, then it might be that the spooling time is much longer than the actual playback time of the songs. And this is also, in other words, the case for data which is stored on tape. So if we access data, if data is stored in a bad pattern on a tape, spooling might take a lot of time, while reading the actual data might be really quick. So yeah, and since these tapes are quite relatively cheap, we store data. We have an archive, as you all know, and we have multiple tape libraries at DKRZ. Here you see 2 of our new libraries. So we have 3 new libraries, and these are 2 of them. And each library has several thousands of tapes and slots, but only a few tape drives and a few robot arms which transport these tapes to drives. So this means that we cannot read all tapes in parallel, like, for example, would be the case for a big server with hard disks. But in this case, if we want to read a tape, a robot arm has to go to a slot, take a tape, bring it to a tape drive, it's inserted, it spools to the correct location, and then the data can be read. And then it has to be rewinded, taken out, and brought back. And if we get many files and one file after each other, this might be very inefficient. Particularly if they are also on one tape, and we get one file after each other from one tape, it might be that the tape is taken from a slot, brought to a tape drive, it's read, then it's maybe taken out again, brought back, then the next file is is requested, then the file is taken again, inserted, and so on. And this a lot of additional time taking out, bringing back the tape, spooling it, rewinding it, and so on. And also it reduces the lifetime of the tape. So the tapes, they have quite a long lifetime, but you shouldn't overdo it. And software can improve tape access. So this SW should abbreviate software. For example, the software which runs atop of the tape library, it can decide that the tape remains in a drive and is also not rewinded when the drive is not needed. Such just the tape remains in it, just in case a user needs again a file from the same tape, that the waiting time is slower, and also the spooling time. And that's one way how to improve it, which can be done on the software side. Another aspect is to combine multiple data requests, which target one tape, to combine them, to send them at once to the system, and the system then optimizes somehow the access. But this means on the one hand side that you or we as users, we have to provide it at one point of time, the request, or in a short time frame, but also the system, it needs to be able to somehow put them together. And in every case, when we interact with the tape library, we have to wait for it, but depending on the way how we access it, how we use it, and what's the software capable of, there might be longer or shorter waiting time. So our setup at DKRZ and many type libraries, it's a way that we have, let's say, our normal or file system here on the left-hand side, the Lastfile file system on which you commonly work. We have the tape library on the left, on the right-hand, on the other side, and then in the middle there's a cache. It's a hard disk cache, and as a software for our tape archive, we have currently StrongLink, or for 4 years now, and StrongLink organizes the process copying from tape to the cache and copying process from cache to Levantum. For this purpose, there's a command line tool provided by StrongLink, which is called SLK retrieve. And when a user requests a file via SLK retrieve, and the file needs to be taken from tape, then it needs to be recalled. So this copying process from tape to cache, we call recall, and then the copy process from cache to Lastfile, we call retrieve. And so StrongLink does this both automatically with one command. Now, what is the actual problem with StrongLink? So why I'm talking about this? So most of you probably had already experience with the issues we have, or some maybe not. So there are actually two central issues to which I will come to speak. But first, our tools. So we have a command interface called SLK that's provided by StrongLink, the official tool. Then we have our own command line interface called SLK Helpers. It's developed at DKRZ. It just adds additional features to SLK. And we provide a script set, which we call SLK wrappers. But everything is available when you load the module SLK on Levantum, then you have everything available at once. And then there's a Python wrapper library, PySLK. And then also, let's say, a third-party packages from other people. They are called packems, which help packing archival stuff, and SLK spec, which is a Python library and add-on for FSpec, for those who know it. And these are libraries, they were originally developed from other people, from our users, but we joined them and somehow support them or support development or do own parts of those. And today I will mainly talk about SLK and SLK helpers. I won't talk about the Python part. So let's have a look at one example case. So we want to retrieve 6 files here to a certain destination location, and these files are just numbered from 1 to 6. One file is flagged as a so-called partial file. This means that the file might be damaged. So StrongLink can flag files as damaged, and we have several cases where files are okay, but they are flagged as partial files, and due to an error in the SLK tool, this flag is not automatically removed anymore, but we have to request the StrongLink, this official support team, the US support from StrongLink, to remove this flag. And these files, they may be stored on 4 different tapes. So the first 2 files are on a tape called tape A, 1 file is on tape B, tape C, and 2 files are on tape D. And then this retrieval command, it wants to get these files, finds out on which tapes they are, starts a recall job in the background, and maybe recall from tape A they succeed, from tape B they succeed as well. Tape C is maybe blocked by a write job. So, for example, new data which was archived previously is currently written by the system onto this tape. And while this happens, now I am trying to read data from this tape, and it's not possible to read data while new data is written onto it. So this tape is blocked in the moment and we need to retry it later. And maybe the other tape D, somehow the access, there comes an error. There are various reasons for this. Error might appear when we access a tape. Reasons might be there's just, let's say, a random tape error, at least from your side, it will look randomly. And sometimes in this case, it's just possible to immediately retry accessing the tape. SLK retrieve won't do this. If SLK retrieve once gets an error accessing a tape, then it realizes, okay, there's an error and doesn't retry it, but actually we could retry it directly. There might be also that the library is taking too long to insert the tape, and then then the StrongLink system has a timeout because the library is too slow. Then we might also directly retry it. But the tape might be also in error state, so there are different error states. They are not automatically resolved, but we have to reset them, or namely ID normally resets them, or we have to ask the StrongLink support to reset them. And this might take a bit of time because the StrongLink support is in the US, or it's the support who does this. And so if it happens in the morning, it takes until the afternoon until such a error state would be cleared in some situations. So and so this might happen in the background. As user, you don't know this, it just happens in the background. And now the retrieve, look again at the retrieve, and we look now at our files again. And 3 of these files from the beginning, they are now in the cache. 3 are not. And files which are flagged as partial files, they cannot be retrieved by users because they might be damaged, and therefore, as a precaution, retrieving them is not possible. It will give an error. This means that the first file, the second file from the cache, they can be retrieved successfully, but the other files cannot for various reasons. You as a user, you just see retrieval failed, 2 of 6 files were retrieved. But you actually don't know which files were retrieved, and you don't know why the retrieval failed. That's not returned to you. Additionally, when we have a high traffic on the StrongLink system, that's the note here at the top left, then there might be just a connection loss of SLK to StrongLink. Then it might also be interrupted in the middle. And so we have various reasons why SLK retrieve might fail a data transfer. And we as the user, we don't know whether we can immediately retry the access. So for example, if there's a random error or interrupted connection, we can just directly try it, or if we should wait some time because tape is blocked or tape is in error state, or if you, for example, need to contact us to remove, for example, this partial file flag. Additionally, it's unclear for you, as I said it already, you don't know for sure which files were retrieved, so you have to go through the folder and check what's there, what's not. That's quite annoying, at least for me when I use it. So, and first step would be to separate the recall and the retrieve in individual steps so that I can better see the error and I better can see what can I do? Can I retry it directly, or should I wait, whatever, or do I need to contact the support? There's another issue. So this is one big error complex. The other is when we retrieve many files, and that was actually a reason of my talk 2 years ago. When we retrieve really many files at once, they are probably on many tapes. Then there's a big recall job running in StrongLink, which accesses many tapes. And if you are the only one user on the system and you do this, then it's fine. It runs perfectly. It runs quick. Or if there are a few other users who do only small things, that's perfectly fine. It runs nicely. But as soon as multiple such really large retrievals or recalls are running, then and if the same tapes are accessed, StrongLink has somehow an optimization routine to optimize the tape access. And this routine is somehow not running properly, and the system becomes very slow. It becomes slow for all users. So not only your recalls become slow, but all accesses of all users to the system become slow. And that's not nice for everyone. And the other point is, if you start a big retrieval, and it fails, for example, due to a connection timeout, then the recall in the background, it proceeds. And if you, let's say, 10 minutes later restart your retrieve, then a new retrieval will be started, which targets the same, nearly the same tapes as before, and you have two big recalls running. And if you should start with retrieval again, then maybe another big recall comes and they all interact, and StrongLink tries to optimize them. We have the same as before with multi-users. The system becomes very slow. And this should be prevented because we want to offer you a fluently running system. On the other hand, let's say running one single SLK retrieve for each file, it's not reasonable, as I said in the beginning, with the tapes, that the tape might be inserted and ejected too often. That would be also not efficient. And so the efficient way is somehow to split each request by tapes, so that we submit a recall job per tape, we collect all files for one tape and submit them together. And that's actually what we did with the tools I presented 2 years ago. And what we did now, we, let's say, improved these tools and added a bit more automatization to this. So then let's start with our improved tools. So actually what our first step was to set up new SLK, so new recall and retrieve commands. They can be used individually, but also with scripts. I present later, depending on the use case for individual. So for if we get back many files, want to get back many files, then I've later automatized scripts. But if you just want to get back 1 or 2 files, or let's say somehow set up your own very specific recall retrieval workflow, maybe in your model setup, maybe it might be very useful to have these basic tools. So there exists an SLK recall and SLK retrieve, but we have more or less overwritten them. No, not overwritten, they can be both used, but we would strongly suggest to use these SLK helpers commands. So the SLK helpers recall, it can target a maximum of 4 tapes at once. So you can provide a list of files to this command or folder, and it starts a recall job in the background in StrongLink. But if their StrongLink needs to access 5 or 6 tapes, then the command it won't start, it will just return an error. The reason for this is that it's allowed to access in a recall job 4 tapes at a time. And if there would be a 5th tape, it would need to wait, let's say, and it wouldn't be very efficient. Therefore, we have this limit. It works similar, like, for example, the sbatch command with SLURM. This command, it just submits a recall job in the background. The recall job has an ID. This is returned, and the command ends. So it just runs a second or a few seconds. And in the end, you have an ID with which you can further work. And you have more descriptive error messages. And you have then, secondly, SLK helpers retrieve. It's in contrast to the SLK retrieves, this command, it doesn't automatically start recalls, but it only gets files which are already in the cache. So I can, let's say, for example, run it in a loop. If I want to get 100 files, I can start the recalls for these files one by one. And during the whole time, I can run in a loop the SLK retrieve, and it always gets me only the files which are already in the cache. And so I prevent the issue that if the SLK retrieve fails, that I again and again submit the same recall again. And you can also get, you have a verbose mode where you can get a list of files which are transferred, or so for each file a status is printed, what happened to this file, if it was retrieved, or if the retrieval fails, and there's also given a reason for the failure. So it's much easier to find out which files couldn't be retrieved. And there's also a flag for this simple command, which you can add. And when you add this, then a SLURM script is automatically built and submitted. So that you do not even have to make your own SLURM scripts. You can just run this command, add the parameter, you see it soon, and that's it. Yeah, so most of this I said already. So the structure of these commands, the SLK recall command, you can provide 1 file or multiple files. As optional feature, you can provide this -d and provide a destination. This is meant, for example, you want to get 100 files back, and some of these files are already in your destination on work, for example, and you do not want to sort out which files are already there and which not. And in this case, you can just provide destination folder, and then the recall command will sort out which files are already in destination, and it won't even try to recall them. It will just get the files which are missing in the destination folder, gets them to the cache. And then the same for the retrieve command. but there's this minus, you provide a list of files, and there's a minus D command is mandatory because you have to provide a destination to where the files are copied in the end. And then the verbose flag to control how much information do you want to see. Now, an example. So I have all examples in these slides. I won't go to the terminal. I just copied the terminal commands here because I think it's just simpler. Everyone can then go through the slides in the end and have the commands, and we don't have difference between what I showed and what's on the slides. So example, we run SLK recall and want to get this one file. Then we get an recall job ID. So it's a number. It is not a SLURM job ID. So StrongLink has its own scheduler with its own numbering. It might look similar to SLURM, but it's different. And then we can ask with a command called job status, we can ask what's the status of our job. In this case, it's still queued on location 18. So there are still 17 queued jobs in front of this job. They are linearly process. So there is no prioritization. So there isn't, in fact, for admins, there is a prioritization, but for you as normal users, they are just processed one after each other. And then while this retrieval, this recall is still running, if we then try to retrieve the file, so SLK help us retrieve, I go into the verbose mode, say I want to have this file, I want to get it to destination, then we get information, okay, this file is not cached, or the command first expects the file is not cached, then it tries to get the file with the result, okay, it's really not cached, then we get the summary, okay, the file was not cached. So this looks a bit much for just one file, but if you want to get, for example, 100 files, you want to retrieve 100 files, 50 files are cached when the command starts, 50 are not cached when the command starts, then expectation would be, okay, I can get 50 files, but 50 files not. But while the files are retrieved, some of the not cached files might be copied in the cache in the background. In the end, more files might have been transferred than originally expected. So therefore there's these two info lines. Right, so in this case, it failed. So what we can do if we do it manually and have a lot of time, we just get a coffee, come back from getting coffee and do again job status and see, okay, it's processing now, but it's not finished. So recall and something else, talk to someone, come back and see, okay, it was successful. And now we can start the retrieval. Expectation is now, well, it's now planned that the file is retrieved. The command tries to retrieve the file, it's successful, and that's it. It's quite nice if we have a lot of time and it works. And if it fails, we see it at some point. If the recall job fails, we see it directly and can somehow react. But I mean, that would cost us a lot of time, but at least you see the facts. So one improvement is here. We have a nice parameter to the retrieve command. The short form is SLURM, and we have to provide a project name, also account name. And what this command then does, it generates in the current folder a SLURM job script. This is this one, and it directly submits the script. If it fails, you also directly get the command to resubmit the script. If you want to stop the script, it's also a stop script generated, or you just cancel the all jobs with this name, because in the background, this SLURM script, which is generated here, it submits itself again and again. So it starts to run, it tries to get the file or the files which are provided here. If the files are not cached, then the script submits itself again and starts in 5 or 10 minutes again and tries it again, and it does this as often until all files have been retrieved. And the name is always the same. So in the name of the shop, there's always the current date and the current timestamp in it. And so it's unambiguously identifiable. And therefore, if we want to cancel this, we just cancel all jobs with a specific name. And there's also one central log file created. So the script writes always a summary of the current attempt into a central log file in the current folder, and detailed SLURM logs are written into a subfolder for details. And so it's, let's say, more or less easy. You can start recall for one or multiple files if they are on 4 tapes or less. You don't know that maybe in the beginning, but later on this. Then you can submit with SLK helpers retrieve the SLURM job automatically and it runs. And you just leave it running. And after 2 hours, if you see, okay, the files are not back, then you can have a look, job ID, and maybe find out what's the actual reason. So it's not that nice, but you have more information and can act somehow or tell us it's not working and we will have a look into it. And then we have more information than in the past. What is quite new and what for me, for scripting, I find it quite useful. For example, we have a file locally which contains a list of resources or files we want to get back. So these 3 files we want to get back, they are stored in this file, which we just print. And we can now pipe content or this pipe content in the new recall and retrieve commands. Actually, if there's nothing provided here on the right, then they read normally from standard in, and therefore I can just use cat to print the content of this file, pipe it into the recall command, and then these 3 files are tried being recalled. And for retrieve, I can do the same, cat this file list.txt into the retrieve command, submit it as SLURM job, and then it just runs. And I personally think that that's quite a nice thing for scripting. In the pad, yeah. Thanks for, yeah. Maybe I start with the last question because I just saw it in the chat. I will read it out loudly. What happens when you don't specify SLURM? Where does the recall retrieve resources come from? So when you don't provide the SLURM parameter, then the command will just run interactively in the current terminal. So if you're on the local node, it will work there. What's important to say when you retrieve data, you need more memory than it's normally available on the login nodes for your session. So it might be that the retrieve command it's killed by the operating system. Therefore, it's a good idea to do this retrieval on an interactive node in the interactive queue. So as alloc, it's documented. Or use this SLURM parameter. But if you don't provide it on the local node, then you just work on the local node and don't use any computing resources. Then I go to the question before. Does SLK recall -d destination check if the files in destination are actually same as on tape? Yeah, so the file size and the timestamp are compared. So if the timestamps differ or the size differs, then they are considered to be different. If they both agree, then they are considered to be the same. So no checksums are compared. So if you should have accidentally a file with different content, but same size and really the same timestamp, then it would be considered as equal. Yeah, and the slides will be available after the talk, yeah. Are there any more questions? Okay, so let's proceed. So maybe some of you or all of you already realized, well, the way how these commands are structured, they can be nicely used in scripts now, are much nicer than the normal SLK commands. And that was actually also the background idea. So actually we started from the script. So the idea was there should be better scripts available. What do we need for these scripts? And then we saw, okay, we need to improve the normal SLK commands for this to improve the script somehow. And these new tools, they consist of 3 commands or 3 basic scripts. The first command, it exists already for 2 years now. It's called group files by tape, or there's also short form GFBT, SLK helpers GFBT or SLK helpers group files by tape. But this was updated and now does a lot more stuff. And the basic idea is actually I tell this command which files I want to get back and where I want to have them later on. And this command, it just generates some text files in the background. And then I start a script called recall watcher. And this actually is a SLURM job, which submits recall jobs in the background, only always a few, so maximum 4 recall jobs. And then it runs in a circle, so it restarts itself. And checks each time, are there still 4 recall jobs running? And if not, I submit a new one, and so on. And so if their data may be on 20 tapes, then for getting data from 20 tapes, we would need 20 different recall jobs. And so this command would always check in each iteration. And if their new recall job can be submitted until all 20 were submitted, and then it will end itself. And when a recall was started, then the recall watcher writes all files which are on this tape. It writes them in a specific file, which is then read by the retrieve watcher, which is also a SLURM job, and which tries to get the files which are already in the cache, or which it expects soon to be in the cache. And it also runs until all files are transferred back. And the main idea is actually that that you just run these 3 commands after each other. First, group files by tape, and then recall watcher, retrieve watcher. You can run the latter two in parallel, actually. And then it runs, and in the best case, it's Friday afternoon. You want to get, let's say, 10 terabyte of data. You just start these 3 commands, and on Monday morning, you come back and say you're all back on disk. If we don't have any access issues at the weekend in StrongLink, then it often works nice. Sometimes it's good to have one more look, but it really works quite fluently in many situations. Before I come to examples, just how this group files by tape, how it worked in the past. So it gets, in this case, a namespace, so a folder with files, or let's say a list of individual files, and then it puts the files together or groups them per tape, which means so it prints one line, for example, with files which are in the cache. So these paths are a bit shortened. So let's assume in this folder there are maybe 7 files with numbers from 1 to 7. And this command groups says 2 files are in the cache. On tape with this name, there are 2 other files. On this tape, there's another file, and so on. And then there's a column here written available, which means that all these tapes are available in the moment. There might be also blocked or failed written. And in the past, you could, based on this output, somehow organize your retrievals and your recalls. So it was somewhat transparent, but you had to invest somehow extra time. As I said, now in the best case, you just run these commands after each other. Group files by tape, start recall watcher and start retrieve watcher. So there are specific scripts to start them. And the recall watcher writes status information into a log file called recalls.log, and the retrieval writes them into retrievals.log. And yeah, and if something doesn't work, you can look it up in these log files. Okay, then let's have a bit more detailed look into these commands. So let's start with this group files by tape command, how it works now. So we added a new flag. So when we want to use this workflow with these watcher scripts, how I call them, you need to add a parameter called WF1, and there has to be follow the destination to which the file should be retrieved later on. And WF1, it's workflow 1. So after having, let's say, a first version of group files by tape, and I added more and more flags, and it grew quite much, and there are a lot of flags now. It's quite hard for a new person, hard to understand which flag is important or not. And therefore, at one point now I thought, okay, I just for each new workflow, there will be just a new flag, WF1, WF2, and so on, so that it's somewhat consistent, and you just take the most recent flag, but we keep the old flags to be somehow download compatible. But the best case, we won't change this anymore, but just in case, yeah. So you provide in the provide folder or list of files from where you want to get data. You provide destination folder in work, for example. And then this command first to you as a user, it prints out the number of files per tape, or here you see this should indicate 2 files in the cache, 2 are on this tape, and so on. It isn't really important for you in this case, at least if you want to use these commands just as they are, it's not that important for you. If you want to do some personal optimizations, you can use these numbers to do some personal optimizations to even increase the retrieval speed, but normally it's not necessary. And then this command creates a lot of files in the current directory. So if we now I do an ls here, we see there's a config.sh created. There are certain variables set which are needed by the watchers. There's a list of all files which should be retrieved. This command actually it also ignores all files which are already in destination. So if a file should be retrieved, if a file from the source and destination has the same name and has the same size and same timestamp, then it's ignored here. It's the whole process directly ignored in the beginning. You can add a verbose flag here to get to know how many files are ignored. So, and all files which are considered are list files all, list with cached files, and then we have files for each tape which contain resource or file list, and in the end, a list of all tapes. This can be quite a large number of files. They have to be in the same folder in which you run these watcher scripts later on because they are based on these files. It's yeah, there are a lot of files. This might have been better with the database, but the idea was to have really basic tool which is quickly to set up and where we don't need to provide much overhead from a central location. What's also possible, I won't show this here, but just you can also use this group files. You can also run it multiple times in the same folder and just append new content. So, for example, you can run it for 10 files first, and then you realize I need one more file, and then you can run it again and append certain parameter, which indicates that you want to append this information, and then this here is updated somehow. If for some reason you want to split up one group files by tapes command into multiple. Now we have these files, and now we come to start the recall watcher. As input parameter, we have to provide a project, a compute time project, because as said, there are SLURM jobs submitted, and there has to be an accounting project from which compute time is used. It's not much, but it has to work this way. And then after it has started, you can look into this recall log file, and there you might see you have first a line. It says, okay, the SLURM job with this ID was started, and you get time and date. And then first what this recall does, it goes through the tapes and it checks what's about the tapes. And then it checks this tape and says, okay, it's available for recall. Tape state is available, and goes to next and goes through all tapes. So not all, at some point it stops. And then it starts recall jobs for up to 4 tapes and says, okay, for this tape, I start a recall job. It has this ID and 2 files are planned to be recalled. And then up to 4 jobs are started. Here you see 4 possible jobs were started. If you work with this a lot, this might be useful information for you. If you just retrieve once a year a big heap of data, you can mainly ignore this. You can just run it. And if you have an issue, you can come to us. And then this information at least helps us to help you better. So you don't have to understand it. You can come to us, help you interpreting this if you have any issues. And now some time passes, and we look again into this recall log, and there's the recalls are running, proceeding, and then, for example, we have information here for this tape. No files need to be recalled anymore because they were successful, the recall jobs. For this tape, there's still this job running, state processing, so it's still going on. And then in the end, there's another tape, a new tape, which is in good state, is available, and there's a recall started for this. And so it goes on until all tapes are processed. And in the recall log, we can see what the status is, if there are some issues or so on. We plan to install a new version of these scripts in the end of this week. There were some bugs in it. Actually, I wanted to release it on Monday, but there were some more bugs, and so we carefully check it again and wait 2 more days with the release. Important here is if recall failed in the current version, then at some point the script will not retry anymore a certain tape. If it fails too often, it will just skip it and proceed with other tapes. This is quite annoying if, for example, a tape was only temporarily not available. then you need to do some manual stuff, cleaning up files. If you have a situation, you can just contact us. In the version which comes out in 2 days, you won't experience this anymore. So it's particularly important for those of you who made this experience in the past, so it gets better in the end of this week. This is this recall watcher. Then we have the retrieve watcher. It works actually the same. So we started, have to provide a project ID, and then we have also log here, and can get information. There's always a summary printed for after. So when a retrieval started, there's information printed into which SLURM log file. There's a subfolder created logs, and there all SLURM logs are written to. And in the SLURM log file, you get details on the retrieval. So for each file, you get a status there. And when the retrieval is finished, then a summary is printed here, how many retrievals were successful or not. So in the end, as I said in the beginning of the section, it works in the way we just run group files by tape with our source file, target destination. We start the recall watcher, retrieve watcher, and then just look from time to time into our recalls and retrieve logs and see what happens. And if it doesn't work for some reason, you can see if you find out yourself or just contact us and we try to help you. What else should you know when you use this? So first, there are most of the time when you run this watchers, 2 SLURM jobs running because when this SLURM script recall watcher, for example, starts, the second thing it does actually is to submit itself again, depending on itself. So let's say when this SLURM job, the idea is when this SLURM job somehow dies due to a timeout, whatever, then there's already his successor. The successor is already waiting and will start immediately afterwards. And this also means if you want to stop these jobs manually, you need to stop 2 SLURM jobs. So the next one and this one. How you do it, I'll show you on the next slide. And also, it might be a bad idea to run this watcher script twice in the same folder, because then they might somehow interact and cause a bad situation. And therefore, when they start, they create a log file. The retrieve watcher creates a log file. The recall watcher, just important to know if it fails under certain conditions, then they might not be cleaned up. Then you need to clean up them manually. But these commands inform you. Just you know, if they say they are log files, then you need to check, are there watchers already running? And if not, you can safely delete the log files. You can stop these scripts manually. So for example, here in this case, I have the SQ command here. So I just print my SLURM jobs, which are currently running. And here you see 4 SLURM jobs and 2 of the name. This name RCLL, which is abbreviation for recall, so 2 recall watchers, 2 retrieve watchers. And if I want to cancel the process, I just need to cancel these 4 job IDs or only the 2 recall job IDs, whatever, and delete later the log file. As I said, there will be new versions updated. This come this week for SRK helpers and the scripts. And with the new SRK helpers which come this week, there's also an SRK helpers top watchers command, which will automatically find out the job IDs of the running watcher script. So you have to be in the folder in which you started the watchers. Then you can run this command SRK helpers top watchers, and all these watchers will be killed. Or you can also specify if only recall or retrieval should be cancelled. I will leave out the Outlook for now and maybe first go to questions. I just check if there's yeah, right. So with GFBT, we didn't implement this. So this piping, it only works with the SRK helpers recall and retrieve commands. Also we added it also. So the issue is here at this point, SRK helpers, they grew historically. Originally, we want to only provide 2 or 3 commands, and they grew. And so we don't have a consistent command design. which means if we have a new feature like this piping feature, we have to add it manually to each command, and this is a bit much work partly, and therefore we only add it to very specific commands. And in the moment, group files by tape doesn't support this piping, unfortunately. We can see whether, if we find time, whether we can add it. In the moment, I think at least in May, it doesn't look realistic. Yeah, one question from Moritz here. So if we run this new workflow with group files by tape, and this is WF1, so this workflow flag, then in the moment, the simplest way was for us, we reconstruct the whole source part of a file. So if a file is will be stored, let's say, in ARC, and then in project, user folder, and in long path in the archive, then this whole long path, it will be reconstructed in the destination folder, and in the end of the path, the file will be located. So the files are not directly copied into the destination folder. We did this because we might have files with the same name in different source folders, and we didn't want to create a situation where you need extra flags, where you need to decide what should happen to these files. So when we have 3 files with the same name in different source folders, they are all copied in the same destination folder, what should happen? And to just have a simple solution for this, we just reconstruct the whole path. It might be annoying in certain situations, but it prevents a lot of special cases. Are there more questions? You can also raise your voice if you wish. Then I would just briefly say a few words on, give a brief outlook, because I mean, from you as a user side, it's quite, I mean, you have the strong system which doesn't work nicely. And also our tools are changing from time to time. It is also annoying if you have workflows, you have to adapt your workflows. That's also not nice. It costs time. It's a question, how will it go on? And to this, I would like to say a few words here. So maybe first, so we had for a long time this HPSS system, and in 2021, we switched to StrongLink. And there will be a new software soon, so in 2026 at some point. We don't know which software yet. We don't know exactly, well, yeah, so which features it's really, so we know which features we want to have, but yeah, it takes some months until until everything is clear, which software comes. And so we can expect roughly 9 months, 12 months time we will have a StrongLink, and after that a new system will come, and our main focus is, let's say, would be to keep the SLK helpers and tools and so on as they are, so that you can just use them as they are. Now we would only make bug fixes. There's one exception. Two of our colleagues are working on a HSM proxy, which is, let's say, a server solution between you and the StrongLink system. They worked on it for several months now. And our main idea was, and the idea is actually let's say, a start and forget system. So you just tell the system, I want to have these files, and then the system does this grouping by tape and transfer, whatever. It does it on its own. It does it for archival and retrieval. That's the main idea. It's still under development. We cannot give a timeline. We hope it will be available as soon as possible, but we cannot say when it will come. And it might also happen that when we have it running, we realize there's another StrongLink issue and we cannot use it with StrongLink. It might be also, I don't hope that, but it might be the case. So it might be that you have, that's a possibility that you need to adapt your workflow one more time, but we hope that normally but this would be only the one time until the end of StrongLink. Our current focus would be, let's say, on the archival in the moment, because in the end of 2026, beginning of 2027, there will be the new HLE 5. And in contrast to the last time all data was migrated from Mistra to Levante. This won't be possible this time. And so is necessity somehow to clean up data on work or to transfer data from work to the archive. This will be partly possible with the new archive software, which comes next year. But due to the large amount of data on work, it's questionable whether it's really possible next year to get everything on tape. And therefore, it might be reasonable if you have already now data on work from which you know, okay, it can be already written to tape. It's 50 terabyte. I don't need it anymore. Then you're welcome to archive it already now. If you don't have the time for this, feel free, contact us, contact support, and we will try to support you, or we can also partly do it for you. Particularly if there are large amounts of data, we will have a look whether we can do it for you. For May, we are quite well booked in the moment, but yeah, just feel free to come to us if you wish. And that was everything for this tech talk. Okay, there's another question on one of our old scripts, SLK wrapper recall wait retrieve. So that was, let's say, one of the previous versions of this workflow. So it's okay. It's okay to use them, to use the script still. The issue with the script is actually that it uses the SLK recall command, and if that fails, it's a bit harder to handle in automated processes. So it doesn't work as efficient, I would say. And in some situations, it will fail where the new commands might not fail. But if you wish to use them, you're free to use them, and it won't cause us any issues. But there's except for one thing. So on our admin side, we see the job scheduler, and we see all recall jobs. And the classical SLK recall command, it always submits a job with the same name. It's just called recall job. And so we cannot see which user submitted it. And there's also no user information attached. And our SLK helpers recall command, it attaches to the name of the user. And it's sometimes quite useful if someone of you tries to get files and maybe a tape is damaged or a tape is not accessible for a longer time. And we know for 2 days, for the next 2 days, it won't be accessible. And if we know which user tries it, then we can contact the user directly and tell you, okay, the tape is not accessible. We notify you when the tape is accessible again. Yeah, but if you use the classical recall command, we won't have the information who is getting the file. We can guess it based on the files and the file ownership, but we cannot be sure. And let's say to support you a bit better, it might be reasonable to use the new recall command and also the new tools. So thank you for your attention. Have a nice day, a nice afternoon. And yeah, hear you soon, see you soon, or whatever. Goodbye.